Assalamualaikum dan selamat pagi. So today we would like to continue our chapter 5, which is root locus. So to sketch the root locus, basically we have 9 steps. First, kita nak tengoklah starting and ending point from the characteristic equation. And the second, we need to know the number of branch that we have. Third, symmetry or not to that our figure from the characteristic equation. And four, we need to know real axis segment. 5, we need to determine the asymptote by using the equation. And then we need to know what is our breakaway and break-in point from the sketching figure. And then we need to finding the j omega axis crossing. Then we need to know the angle of departure from the complex poles or angle of arrival to complex zero. And lastly, we need to calculate the value of k on the root locus. So now we can continue for step by step. Okay, based on the properties of root locus, some rules are established to enable us to sketch the root locus. So first kita nak tengoklah starting and ending point. So what is starting and ending point? So kat sini kita ada characteristic equation 1 plus gs hs equal to 0. Begin at the poles of the open loop transfer function gs hs and end at 0 of gs hs as k increase from 0 to infinity. Therefore, there are two observations on this statement, which is first we need to find the starting point. So bila starting point, we look at the poles number, and to find the ending point, we look at the zero number. So if the number of poles n is bigger than the number of zero, then the remaining locus at n at infinity. So then we need to calculate the number of locus that n at infinity, which is n minus m, itu poles minus zero number. So we look at the example. So diberi k gs hs equal to k divided by s plus 1 s plus 2. So here we need to determine what is our starting point and ending point. So kalau kita kata nak tengok starting point, we look at poles number. So poles ni adalah pada bawah lah kan. So the poles number value we have 0, negative 1, s plus 1, kita tukarkan jadi s. So we get minus 1 and minus 2. So we have 3 point. And then 0. 0 sini tak adalah kan, bila tak ada 0 point. So now we need to calculate the number of locus that end at infinity by using this equation. So kita untuk dapatkan the number of locus that end infinity, we have 3 number of poles minus number of 0. So we have 3 minus 0. So we have 3 here. 3 ni maksud adalah the number of locus that end at infinity. Okay. So step yang seterusnya, we need to calculate the number of branch. Okay, dia kata kat sini number of branch. Berapa branch yang kita ada? Selalunya basically the number of branch is follow number of poles. So kat atas ni number of pole kita ada 3. So that's mean number of branch kita ada 3 lah. So step yang seterusnya, symmetry. The root locus is symmetry about the real axis. Okay, so kat sini adalah example lah. So kat sini we have the number of pole at 0 and 10. So symmetry dia adalah berada di tengah-tengah lah. So 10, 0 dengan negative 10, symmetry dia adalah pada negative 5. Okay, the next step is real axis segment. Okay, apa itu real axis segment? Okay, if the total number of real poles and real zero to the right of the test point is odd, this point lie on the root locus. So kat sini kita ada characteristic equation that we have K times with S plus 4 times S plus 3 divide by S plus 1 S plus 2. So untuk kita buat real axis segment, we need to sketch for our poles and zero number. Okay, so we have sini kita ada J omega and this is our real axis. We draw for the S plane. So kat sini kita ada kat sini S plus 1, S plus 2, this is our poles number. So we draw lah. Poles kita ada negative 1, negative 2. And then our 0, we have negative 3 and negative 4. So S plus 3, S plus 4. We transfer to S plane, we get negative 3 and negative 4. Okay, so this is our real axis segment. Okay, the next step is we need to determine the asymptote. So what is asymptote? Okay, asymptote is the root locus approach straight line as asymptote as a locus approach infinity. The equation of asymptote is given by the real axis intercept sigma A and angle A as follow. So this is our equation that you need to use to determine the asymptote number. So for to determine the intercept, so intercept ni adalah titik tengah lah di antara poles and zero. So sigma A equal to summation of finite poles minus summation of finite zero, and then we need to divide by poles minus 0. Okay, then to determine the angles number of the value, we need to use this equation. So theta A equals to 2k plus 1 times pi and divide by n minus m, poles minus 0. So k starting from 0, 1, 2, 3. So where k is 0, plus minus 1, plus minus 2, plus minus 3, and the angle given in the radians with respect to the positive extension of the real axis. So we look at the examples 5.2. Okay, this is example to determine the asymptote value. So given figure 4.14, so we have, this is our characteristic. Okay, solution. First we need to determine our sigma A. Sigma A, we have summation number of finite 0 minus summation of finite summation of finite poles minus summation of finite 0. So we have, now we have negative 1 minus negative 2 minus negative 4 minus negative 3 divide by 4 minus 1. 4 ni adalah the number of value, the number of point of poles. So the number of pole we have 1, 2, 3, 4. So kita ada 4 point minus 1. So here we just have 1. So we get -4 divided by 3. Okay, this is our finest 0, sigma A. And then we need to determine the angle of the line that intersect at -4/3. So by using this equation, 2k plus 1 times alpha and divide by poles minus 0. So for first, we use k equal to 0 and we get pi/3, and then we change k equal to 1 and we get pi, and then we change to k/2, so we get 5 pi/3. So this is the step how we gonna to calculate our asymptote value. Okay, we can continue for the next part.